guys, welcome back. We are still doing the SAT Prep Test 5, Module 1 on the math portion, and we are on number 17. So whenever you are solving a problem like this, when you're looking for an equivalent expression, you want to look for like terms, and we have two pairs of like terms here and here. The important thing for this particular problem is to make sure that we distribute this negative to both terms. Again, you could easily type this into Desmos, but I do want to show you how to do this without it just in case. After we distribute that negative, we're going to get the result of negative x cubed plus 2. 8x cubed minus 1x cubed is 7x cubed, and 8 plus 2 is 10. So our answer is B. If 4 radical 2x equals 16, what is the value of 6x? Here we're going to utilize inverse operations, and that's going to allow us to solve and isolate x. So we are going to divide both sides by 4, where we're going to get radical 2x equals 4. Then to undo a radical, we are going to square both sides. So we're going to get 2x equals 16. Now it's easiest, since we're looking for the value of 6x, to just go ahead and multiply this whole thing by 3, and that's going to give us the direct result of 48. Number 19, 2x minus y is greater than 883. For which of the following tables are all the values of x and their corresponding values of y solutions to the given inequality? So you have two options here. I'm going to go ahead and plug this into Desmos to show you how to do this, but you could also simply take these values and substitute them in for x, and then take their corresponding y values, plug those in for y, and see if you get a result that is greater than, or just greater than 883. But you'd have to do that 4 times. So I think in this case, it's going to be easier to hop over to Desmos. Okay, so we're going to go ahead and type in 2x minus y is strictly greater than 883. All right, so we're going to have to zoom out a little bit because 883 is the y-intercept is very low on this. We are going to be looking for these points on our graph. So 400, 0, 440, 0 is to the left of this point, and that is not included in our solution set. So anything with 440 and 0 is not going to work. 442, 0, both of those are good to go. 441, negative 2. 441, negative 2 would be to the right of this point, so that's also good. 441, negative 2, yeah, it's going to be this guy, option D here. For this particular question, you can go ahead and plug this into Desmos, but I do think it's easier to show you guys how to do it via elimination. Based on the fact that we have two opposite variables right there, we have 5y and negative 5y. If we were to use the process of elimination here, we can add straight down and our variable is going to cancel immediately. So it's actually much faster to do it this way. Okay, once we come down here, we're going to get 0 equals 15x minus 11. We'll add 11 to both sides, then divide by 15. So we'll get x equals 11 over 15. Now we're looking for the value of 30x. So what we're going to do is multiply this by 30. So we get 30x equals, what's going to happen here, since 30 is evenly divisible by 15, our result is just going to be 2 times 11, which is 22. A rectangle is inscribed in a circle such that each vertex of the rectangle lies on the circumference of the circle. The diagonal of the rectangle is twice the length of the shortest side of the rectangle. The area of the rectangle is 1089 radical 3 square units. So what is the length in units of the diameter of the circle? Let's go ahead and sketch this out. So we have a rectangle inside of a circle here, it says that each vertex lies on the circumference of the circle, and the diagonal of the rectangle from here to here is twice the length of the shortest side of the triangle. Shortest side of the rectangle. Okay. So you might recognize the fact that we have a 30, 60, 90 ratio here. We know that a rectangle is going to have a 90-degree angle here. We also know that when the sides are in the ratio for a 30, 60, 90 triangle, we have 1, radical 3, and 2. It tells us that the area of the rectangle is 1089 radical 3 square units. So that tells us that if we have 1089 radical 3 equals length times width, and we're calling x our width here, since we know that our hypotenuse is 2 of our triangle, our shortest side is x, or 1 in this case, 1x. That tells us that our third side, which is going to be this guy down here, is going to be our radical 3x. So we can replace this L with radical 3x, and this is how we'll solve it from there. From here, we can go ahead and divide both sides by radical 3. It's nice, it's going to cancel out. 1089 equals x squared. Then we simply take the square root of both sides, which turns out to be 33. Here's number 22. Rectangles ABCD and EFGH are similar. The length of each side of EFGH is 6 times the length of the corresponding side of ABCD. Let's go ahead and sketch this out. It is important that you label them the same. So for instance, A needs to go with E because they're in the same position here. B needs to go in the same position as of F, and so on. C and G and D and H. Okay, so that's just something to point out there. We know that EFG is 6 times the length of the corresponding side, so let's just call this X. That's going to make this 6X. Then we know that if this is, let's call this one Y, that this is going to be 6Y. The area of ABCD is 54 square units. So we know that XY equals 54 because the area of a rectangle is length times width, and we have denoted those by X and Y. So we know that this side over here on EFGH is going to be 6x times 6y. That's going to be the area, which is 36xy. What is the area in square units of EFGH? Well, we can go ahead and substitute 54 in for this value right here. So we have 36 times 54, and that answer is going to be 1944. Make sure that you guys go ahead and subscribe to see the rest of these solutions worked out. We are going to be working through this entire test, and especially with the SAT coming up, you want to make sure that you can know these special tips and tricks. So thanks for following along.